Greetings, we are Team 336-1, Galactic Zamboni. I am Devin. These are my teammates, Ben, Seth, and Jonathan. This year our project is having robots play air hockey.
Our project uses 3 robots to play air hockey. One robot is user-controlled using its control panel, while the other one is autonomous and uses 2 IR sensors to track the puck. The robots drive back and forth in wooden channels and use 3 motors to move, including 2 that are used to operate the arm. Now here's Seth to talk about the user-controlled robot.
For controlling the user-controlled robot, we have a control panel which has a wheel that we use to swing the arm back and forth to intercept and hit the puck. We also use XB radios to communicate messages between the controller and between the robot itself. And then we use other touch sensors used to actually swing the paddle and to move the robot back and forth in the track. And now here's Jonathan to talk about programming.
So our user-controlled robot gets a message from our controller with 4 major parts. It then parses this message into 4 separate areas, and then it tells each part tells the robot to do an action like move left or right, swing the arm, or hit the pad.
The autonomous robot is identical to the user-controlled robot in every way, except it has these 2 additional IR sensors. The IR sensors are for picking up the puck here, so we can grab its distance, and then here, and grab its distance again. We time the distance between the 2 picking ups, and from there we can calculate speed and trajectory. I'm going to show you a little bit more at the whiteboard.
So our autonomous robot will also display the trajectory of the puck hitting the wall by taking the 2 distances from the IR sensors and putting the 2 points on a coordinate grid. It will then draw a line from one of these points, passing through the other, and then hitting the wall, showing where on the wall it will hit.
So the first sensor picks up the puck here, and we start a timer. The second sensor picks up the puck here, and stop the timer. Then we know the time it took between the both sightings, so we can figure out the speed since we know the distance. So using these 2 different distances, we can figure out the angle of a hypothetical triangle right here. And since we know the distance from here to here, and we know the distance of the table, which we've measured and then coded in, we can figure out the first leg of the hypothetical triangle, which we'll call A. So if we use some simple trig, or tangent actually, to figure out leg B of the hypothetical triangle. And that's important because it's our first distance. So then we simply use Pythagorean theorem, squaring them, taking the square root, to figure out the hypotenuse of our theoretical triangle. Then we construct a secondary similar triangle over here. We know that this angle is the same, and so then we use the distance from the sensor, or where we pick up the puck, to the edge of the table, which we also know and measured, and using a little subtraction we figure out B sub s for smaller triangle. So, and in this case, since we know the angle and another leg, we use, once again, a little more trig, sine in this case, to figure out the hypotenuse sub s. And then once we know these 2, we use Pythagorean theorem to figure out A sub s. And A sub s is actually the distance that we need to drive from this side of the wall to where we will intercept the puck. Then, because we know the speed from figuring out the timing and the speed earlier, we just add the 2 hypotenuses together, and we can use the speed and the distance to figure out exactly when we need to react.
Here I'll demonstrate the user-controlled robot. I can see the right button will move the robot to the right, the left button will move the robot to the left, the button will make the paddle swing, and the motor will cause the arm to go left or right. So as you can see, I can hold it, go all the way over to the right side of the table, move the arm and hit. I can also do the same to the left side of the table, move the arm and hit. So if a puck came right here, I can hit it like that, and that's how it works.
The full thing isn't quite ready to go yet. We're experiencing some small hardware difficulties with our sensors, where they're having issues reading some faster moving objects. So we're going to go ahead and show you what it looks like if we just have a really slow moving object. So quick demonstration. First sensor picks up the puck, second sensor picks up the puck, so we'll move the intercept, and hit it. So I'm going to reset the puck, reset the robot, restart the program, Then we're going to do it at a different angle. First sensor. Second sensor. Move it around a bit, sometimes it doesn't pick it up right off.